Hey everyone, welcome back to our channel. We've all seen the rise of Agentic AI that's quickly evolved from generative AI. Agentic AI systems are more than just chatbots. They are autonomous agents that can perceive, plan, and execute multiple tools to complete complex tasks. This flexibility and power also makes them a black box. In this video, we will open up that black box through the clear lens of observability principles like monitoring and tracing. We will explore what's different in agentic AI systems against traditional software systems, and we will dive into the core tools and techniques you need to gain control of your agentic AI systems. So let's get started. First, let's look at the key challenges while operating agentic AI systems and why observability plays a central role in overcoming them. Have you encountered these common issues? Agents are not following instructions that you have laid out in the prompts. The tools that are getting selected are not really relevant for the task at hand. And finally, you're struggling to do root cause diagnosis of the errors because you do not have a clear view of what's going on with your agents. The fundamental challenge with these systems is their inherent variability in execution and decision making. This is not like traditional software which gives a predictable output most of the times. Agentic AI systems, on the other hand, have flow variability firstly, meaning that their execution paths can diverge even if you give identical inputs. Because agents, remember, are multi-step. They are non-deterministic and they also frequently interact with external tools. Secondly, they also have a natural language variability, which means that a slight change in phrasing the input can lead to a completely different result. Now, these factors make your agent's behavior unpredictable and incredibly difficult to debug. You cannot control costs or prove compliance. So this is where observability really becomes critical. It is not just a tool you bolt on at the end, it is a foundational part of the entire AgentOps lifecycle, and we will shortly see what that means. Now let's define observability for AI agents. It is the ability to understand an agent's internal state and behavior by analyzing its external outputs. It is an extension to traditional software observability, but here the focus is shifting to adapt to the unique complexities of AI agents, which means that metrics are specific to AI agents. The way the events are traced and logs and traces are tracked is very different. Let's look at an AgentOps lifecycle. It typically starts with making design decisions suiting the business problem and then quickly goes on to developing the agent. Once the agent is developed, we do evaluation and testing to ensure that the performance is up to the mark and everything is working as expected and fulfills the acceptance criteria. Once that acceptance criteria is fulfilled, the next stage is deployment, where it is deployed into production systems. And finally, observability comes in at the operate stage where everything is happening and you want to see really what's happening inside. Observability basically deals with providing a continuous feedback loop that informs every other stage, from development and testing to deployment, because you want these systems to improve over time. And that is why observability is a very central part of the agentic puzzle. It is the only way to get a clear view into agents' behavior in production. For instance, in the design and development phase, it can enable continuous improvements. For evaluation and testing, it helps with diagnosing root cause of errors. And think about reliability. It serves as a foundation for reliability practices, because if you're changing any configuration about the fallback model or load balancing, you really want to evaluate whether that config change has improved your overall system or not. Also look at compliance. Observability enables an auditable trail, so you can really prove that you were compliant. And because you have a view of what's going on, you can also have a centralized view for cost and usage patterns, which enables governance of your agentic AI systems. Now let's dive further into some of the concepts and explore the first pillar, which is monitoring. Monitoring is about continuously tracking key metrics to understand your agent's performance, engagement, and cost efficiency. There are three types of metrics that you must track to make your agents production ready. The first category is foundational metrics, which an observability dashboard could typically track. KPIs like latency, token usage, and cost. In latency, for example, you can track end-to-end request latency or time to first token or inter-token latency. And we will explore them in detail in the next slide. All of these metrics give you granular visibility into your application's health and budget. Then there are quality metrics. Unlike traditional software, you need to track the quality of an agent's output. These metrics, such as answer relevance, hallucinations, and toxicity, are crucial for ensuring your agent is providing helpful, accurate, and safe responses. Finally, there are error metrics. You need to quickly diagnose issues, right? You can track error rates to identify performance or reliability issues with specific models or specific areas of your code that you're using, as well as you can break down errors by error types. Think about what else you can do. You can track latency spikes to privacy issues and link them directly to the specific trace or span where they occurred, enabling a very thorough root cause diagnosis. Now, at what level can you really perform this monitoring? There are different dimensions. You can do this at a prompt level, you can do it at a model level, at a user level, at a span, which means a run level, you can do it at a trace level or session level. This breakup by comprehensively different granularities makes these metrics even more relevant and powerful. Now let's dive a bit into latency because that's really important and what latency means really in the context of agentic AI applications. You would commonly refer to latency as the time between input query and output response. And that's exactly right. What we would do here is we would refer to that as the end-to-end request latency, the latency between the input query and the response, which is the complete time. And if you see the schematic towards the bottom, you would see that this end-to-end request latency is composed of two key metrics. The first one being the time taken to generate first token since the input has come in, and the second being the generation time once the first token is generated, which basically is a function of the time between individual tokens, consecutive tokens. Right? Formally, the first one is called time to first token metric, and the second metric we would define as the inter-token latency, which basically affects the generation time. I hope the concepts are clear till this point. Now, if you think about these metrics, do you expect these to be exactly same across each prompt output instance? Probably not, because they can also vary, and we will explore what causes variations shortly. But before that, since these metrics vary, what would be your actual KPI? That's where we would think about tracking the P99, P90, and P50 percentiles of these metrics in a common case. For instance, the P99 metric means that if the P99 request latency is 1 millisecond, that means that 99% of the requests had a latency lesser than 1 millisecond. So it's the maximum latency for 99% of the requests. That is what is meant by P99 percentile latency. Similarly, P90 and P50. Now, coming back to what is causing these variations, why each prompt output instance could have a different latency. Let's look at the reasons. So let's start with time to first token. The first thing that can really cause changes in this is the request queuing time, which is the duration a user's request spends waiting before the LLM system begins processing it for inference. This waiting period occurs because, let's say, the system's resources like GPUs are fully occupied with other requests, and new requests must be held in a queue until capacity becomes available. So request queuing time actually affects the time to first token since the input has come in. The second one is network latency. And think specifically if your agentic AI systems are deployed on cloud GPU instances. Since LLMs require massive computational resources, they are often distributed across multiple GPUs or nodes, making network communication a key factor in overall efficiency. And finally, prefill time. Prefill time basically is the duration it takes for an LLM to process the entire input prompt and generate the first output token. And this is a process that involves complex parallelized computations and the creation of a KV or a key value cache. So prefill time also depends on the LLM you are using and a few other factors. So this can also affect latency. Now, if you think about the inter-token latency, what really affects that? That's the decoding time, because once one token has been generated, now it is the decoding process. So the decoding time actually affects the generation time and in turn the inter-token latency. One key point about the inter-token latency is that these should, in an ideal scenario, be very consistent most of the time, and that would imply generation efficiency, right? Okay, there are a few other metrics like tokens per second, which is a throughput metric, but we will not really go into them here. Now let's look at some of the quality metrics. The first one is answer relevance. How relevant is the response generated by the Agentic AI system or the LLM compared to what the user had originally asked, right? So is the answer also really relevant? You have to track that. Second one is a common known one, which is hallucination. Is the model making up facts or is it grounded in the context that it already has, right? Because if it doesn't have the necessary context, that is a very common case for the model to hallucinate. And third one being toxicity. How toxic is the generated response? And we typically measure this in terms of the number of opinions which are expressed in the generated output. Now, if you think about all of these three metrics, these are a function of three key dimensions: the user question, the context which the LLM has, and the generated answer. For example, answer relevancy deals with the user question and the generated answer. It's comparing these two and answering the question whether the generation is relevant to the question asked. Similarly, hallucination is just dealing with the context and the generated answer for the most part, right? So whatever the answer has been generated, is it really referring to the context or to facts that the LLM has, or is the LLM making up facts? And finally, toxicity is a function of the generated answer, where the generated answer is evaluated for any toxic information. Okay, so we have covered monitoring till this part, and we have really understood what are the key metrics and what each of these metrics really mean. Now, let's look at the second pillar of observability, which is tracing. Now, while monitoring gives you the big picture, tracing provides a comprehensive view of every step your agent takes. It is all about the execution process, right? So this is especially useful once the agent developer has deployed their agent, because they can trace its execution process to understand and monitor the entire life cycle, from prompt to model selection to the fallback path to cost to output, right? And tracing also performs a metadata logging, right? Because it does log attributes like user ID, team, tool, region, the latency, and the tokens consumed. And this metadata is what makes tracing so powerful, right? You can really debug a lot of failure scenarios. And we will look at one shortly. Okay, so let's think about a failure scenario. Something has failed, right? What can you do with tracing? You can follow a user's prompt and see that, let's say if model A failed, it triggered an automatic fallback to model B, right? In general, you can have audit trails, which are immutable logs of all access and usage events supporting forensic analysis and compliance audits. Secondly, you can also track cost variance between the two models in this scenario to understand the financial impact of the failure. Generally, you can also attribute cost by team, user, tool, or model to support budgeting and internal chargebacks. Finally, you can pinpoint where the error handling occurred to ensure the system behaved as expected in this fallback scenario. And in general, you can trace errors back to the root cause and perform a lot of error RCAs. Now, let's deep dive into some of the concepts of tracing. The entire execution of a workflow in an agentic AI system is called a session, which is made up of one or more traces. A trace is a smaller part of a session. It is a detailed recording of a single request's execution path from start to finish, right? So we are dealing with a single request here instead of a session, which is basically the complete instance of an AI agent workflow. A trace in turn is composed of individual spans. These spans detail every single action your agent takes, allowing you to follow the entire process from a user's initial query to the final response. This helps you pinpoint problematic requests and trace errors back to the root cause. Now, there are a few common spans, right? We can think about agent spans, which show the dynamic reasoning steps an agent takes to complete a task. For example, if you think about a React agent, it might represent a series of reasoning steps controlled by that agent. The second most common type of a span is workflow span, which represents a static sequence of operations, like a process that takes a document link and returns a summary. The third one is LLM span, which represents a call to a model where inputs and outputs are expressed as text. So this LLM span typically does not have child spans because it is a standalone operation. And a tool span is a call to an external service, right? And that's basically executing a tool. So that is also traced. There are a few additional spans like retrieval span, right? Embedding spans and chain spans, which basically track individual processes. Like in retrieval, you track the vector search operation. In embedding, you track the generation of an embedding, and in chain spans, you basically track the starting point or the link between different steps of an LLM application. Now, this is all well and good, right? We have understood the concepts of observability. We have understood monitoring and tracing. And we have seen how these would really help overcome the challenges of agentic AI systems. Now, one key area here is AI Gateway, where AI Gateway really helps enable observability. Let's discuss the role and why AI Gateway is very, very easy and critical for enabling observability. First, a quick recap of what an AI Gateway is. It is a central control panel for building agentic AI applications. And technically, it is a gateway to four major components of building agents: models, prompts, MCP servers, which basically enable tools, and other agents, right? So think about the A2A protocol. So AI Gateway basically covers all of these four key components of building agents and working with agents. It is the architecture that makes all of this possible. Now, because all of the AI traffic flows through a single centralized point, the gateway is perfectly positioned to provide complete observability. It logs every session, trace, and span, and it creates an auditable trail you need for governance and compliance, right? Further, it monitors every token. You have latency spikes also, which are monitored, and you get very granular data you need to proactively manage costs and ensure reliability as well. Now, all in all, observability is not really a luxury for agentic AI. It is a very, very basic operational necessity. And the AI Gateway is well positioned to be that architecture that makes it possible. You can make that black box of agentic AI into a transparent, auditable system. And you make sure your agents are reliable, your data is secure, your costs are predictable. You basically make your entire agentic AI accountable. Without observability, you're not in control, you're just guessing. So make sure to enable observability, and I hope you also understand the context where AI Gateway really helps enable observability very, very easily because it's positioned well. Thank you for watching.